Hello students, how are you all? Students, welcome in this class. And in our previous class we had discussed about the IUPAC of halogens and different functional groups, and today we are here for saturated and unsaturated hydrocarbons. So you know that where the valency of carbon and carbon is fulfilled by single bonds only, that is called the saturated, and when double or triple bonded will be there, that situation is called the unsaturated. So unsaturated are either alkenes or alkynes. Now nature, alkanes that are also called the paraffins and alkenes are called the olefins. It is important to know that paraffins and olefins. Okay, now these are saturated and these are unsaturated both. They contain single bond, and alkenes and alkynes contains double or triple bonded. Molecular formula, that is here ethane, methane, and here ethene, ethine. Okay, now next thing is structural formula. Here you are seeing, you will write the carbon, then you will fulfill it by the hydrogens here, and in this case the IUPAC name, that is ethane, and in this case ethene, E and E will be there, and here Y and E will be there, ethine. Okay, now saturated organic compounds. Students, you know that saturated organic compounds, there will be single bonds only. So here the special structure features that is given here, single covalent bond, and in this case double covalent bond or triple covalent bonds will be there. Okay, now all the four valencies of each carbon atom are satisfied by the hydrogen atoms forming single covalent bond, and here at least two carbon atoms are not satisfied. Okay, so you will fill it by single, double or triple bonded. Okay, the non availability of electrons in the single covalent bonds make them to less reactive. Okay, since it is saturated, so it is less reactive and therefore undergoes characteristic substitution reactions only, and here in this case they are more reactive, so they are able to give the addition reaction. They are give the addition reaction due to its unsaturated nature, it gives the addition reaction. Okay, now characteristics reactions, here substitution reactions is given here. In substitution reaction, it will substitute its hydrogen by chlorine, fluorine, bromine, iodine, and it will add with the hydrogen, fluorine, chlorine and bromine and iodine for yielding a saturated product. Okay, now alkenes, here you know that alkenes they are unsaturated and alkanes are saturated, है ना. तो alkanes they are saturated hydrocarbons where carbon carbon covalent bond is single covalent bond, and its formula is CnH2n+2, and they are called the paraffins also. Okay, these alkanes are called the paraffins, and in case of alkenes you know that its distribution, these are widely distributed in marshy lands, they are called the marshy lands. So methane is called the marsh gas also. So these alkanes are distributed in the marshy lands, air and coal mines, and main sources that is natural gas and petroleum. Okay, natural gas contains 75% methane and is also found associated with petroleum. This marsh gas, it produced by bacterial decay of vegetable matters containing methane, and fire dams, coal pockets, they contains large amount of methane. Okay, now this methane is acts as the greenhouse gas also, and the nomenclature of alkanes is, you will write here N as its suffix. So one carbon is here, so you will write the meth, and N you will join, so this one is methane, then ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane. Okay, this is given here, and then structural formula of methane, ethane, that is given here. At first you will write the carbon, then the carbon you will show by the cross, and one another hydrogen you will show by the dot here, so you will join here the hydrogen and will give easily its formula, and the formulas are given here are very important. Okay, now this one is the structural formula. So methane, you know that carbon has 4 electrons in the outermost shell, which are shared with 4 electrons of 4 hydrogen atoms, that is 1 carbon atom joined to 4 hydrogen atoms by single covalent bond in this case. Okay, and like methane, ethane is also. Now alkenes, so methane you had studied, so here methane, ethane, and alkanes. In alkanes, methane, ethane, propane, butane, pentane, many things are there, but here you will study about the preparation and physical chemical properties of methane and ethane. So first one is methane and ethane here. So laboratory preparation, how will you prepare it in the laboratory? When sodium acetate react with soda lime, that is called the sodium hydroxide, in presence of calcium oxide and heated, finally you will find this methane, and it is very important reaction. Okay, now next thing is by the sodium here, you know, sodium propionate. Okay, this sodium propionate and soda lime react with presence of calcium oxide and heated, gives the ethane. This is the laboratory process of preparation of methane and ethane, and the figure is given here. Here you know that this soda lime and calcium oxide is there, and when it will be heated, then it produces the methane gas in the gas jar. Okay, and bubbles will come outside. Okay, now here with the help of sodium acetate and sodium propionate, with help of sodium acetate methane produced, and with help of sodium propionate ethane is produced. Now this was the laboratory preparation of methane. When the question will be that how will you prepare the methane and ethane by the laboratory process, then you will give this reaction only. Now general methods, many general methods are here. So methyl iodide react with nascent hydrogen, and activator is copper or zinc, so then you will find methane here. Okay, now and hydrogen iodide is released. Now bromoethane, this bromoethane that react with nascent hydrogen gives ethane and HBr, and same here methyl iodide react with sodium gives the ethane and sodium iodide. Okay, now physical and chemical properties you will study. So at first you will study here about the physical properties of methane and ethane. So physical properties, this gas, these both gas at ordinary temperature colorless and odorless, almost insoluble in water. Okay, and in organic solvents these are soluble. Examples, organic solvents like acetone. Okay, melting point and boiling point is given here. And now vapor density of methane and ethane, that is given. So vapor density is 8 and its vapor density of methane is 15. Okay, now in our chemical properties we will study that they gives the substitution reaction because they are saturated hydrocarbon. So here methane, when it react with chlorine, will give the methyl chloride and HCl released, and when this further gives the reaction with the chlorine, dichloromethane, and further it react with chlorine gives trichloromethane, and then finally it will give the tetrachloromethane. It is very important. This is the substitution reaction given by the saturated hydrocarbon. Now ethane, very same, it will also react with the chlorine to give the chloroethane, then dichloroethane, then trichloroethane, then tetrachloroethane, and finally pentachloroethane, and after that hexachloroethane, and releases HCl in all cases. Okay, then oxidation reaction, when it will oxidize, that means react with the oxygen, it gives the carbon dioxide and water and releases the heat. Okay, these are exothermic reactions. this one is also releases the carbon dioxide and water plus heat. Now incomplete oxidation if will be there, so it will release the carbon monoxide gas which is poisonous, and water and heat, these both. Ethane also releases carbon monoxide and water. Okay, now chemical properties here, if these will be oxidized will form the alcohol, so this methyl will form methyl alcohol, that is called the methanol, and ethane form the ethyl alcohol, that is called the ethanol. Okay, now when ethanol is oxidized it gives the formaldehyde group. Okay, and here ethanol is oxidized, it also gives the formaldehyde. Okay, this one is methanaldehyde and this one is ethanaldehyde. Okay, now if methane is burned, you know that if any hydrocarbon, saturated hydrocarbon, when it burns it gives the, here with the help of oxygen it gives the formaldehyde which is called the methanol, and this one is called the ethanol and also called the ethanaldehyde. Okay, now controlled slow oxidation, here alkanes, alcohol, aldehyde and then acid, these are converted in these forms. Okay, now methane converted alcohol, then aldehyde, then carboxylic acid, that means on the oxidation oxygen will be added there. Now in ethane very same process is there. So now in presence of oxidizing agent like K2Cr2O7, when this oxidize it will form the formaldehyde and then formic acid, methanol, sorry, this is called the methanaldehyde and IUPAC is called the methanol, and this will form the ethanoic acid. Now pyrolysis, when pyrolysis will be there, so at high temperature it gives the unsaturated compound ethane and hydrogen released, and ethane it gives the ethene. Okay, now uses of methane and ethane, so you know that illuminants and domestic fuels, for this purpose it is used, and also in manufacturing of chemicals like chloroform, carbon black and formaldehyde, methanol, ethanol, for these all purposes these are used. Okay, that's all for today. In our next video we will discuss about the alkenes. Till then, thank you everyone.